So obviously you would get negative 6x to the negative 4 times, right? Does that make sense? That's what I got. Yeah, and that's correct. Okay. But then you have.
All right. Here we go. I like this. This is good. So this first one, do we all agree? Do you concur? 2 plus 8 plus 3? 13. All right, so end of the 13th. So I started you off nice. This one, you just take the 3, the cube, and you just do that to everything. So 3 cubed is 27. Good. 3 times 3 times 3.
X.
Good. You multiply when you raise. Right?
And here's where I go downhill.
So real quick, it wouldn't make any sense to do 3 times 3 here, right? Because I'm cubing things. But people get confused because I do 3 times 2. But that's not the number 2. I'm cubing x squared. And the way you do that is you multiply the powers. It's going to come into play here in a minute. Powers will not act like numbers do because they're not the same thing. All right, here. I cannot, in my next level, I can't have a bunch of pluses and minuses running around because I don't have any addition subtraction right now. I can't suddenly introduce it. But I do have a bunch of multiplications, so I can multiply in a smart order. Negative 2 times negative 3, 6. 1x times another 2 x's, x third. 4 y's times another 2 y's. And you're done.
I thought you had to stay within the parentheses in each one first before you...
Definitely. I love it. Is there anything to do in either one of those parentheses?
Oh, so if there's not, then you can...
Oh, hell yeah. Because the first step, I agree, is do whatever you can in parentheses. The next step is exponents. I can't do the exponents even. Next step is multiplication of it. Okay, now I can start multiplying.
Okay,
Cool.
so you come down.
Yeah.
I got all of it, but I got 6x squared.
I don't know. Because you already have 2 here, and you're multiplying that. Remember, there's an understood 1 there, right? It's not a 0 there, or else this wouldn't even show up.
Yeah.
So 1 plus 2 just gives 3. No. All right, so number 4. I'm going to do it the way that most of you guys did it. And I saw I saw some of this here where it got an 8. Where do you think somebody got an 8 from?
Multiplying.
Subtract, because your brain, again, just like I said earlier, they think, okay, you're going to subtract 8 and 10, so of course now, Jeff, this math shit changes all the damn time, so now I'm going to start subtracting numbers. No, math does not change. 12 divided by 4 is 3. I don't care what freaking math you're looking at, or what section we're in, or whatever. But powers are not numbers. They won't act the same way. We know how powers act. Division involves subtracting the powers. Cool? Another problem I see sometimes is I get x to the 0.8 or something freaky here. Or x to the, what would it be, 4/5 or something really strange. Do you guys see where that comes from? Alright, just never do that. We know what happens here. So 12 divided by 4 is 3. X to the... Now what's being raised to a negative power? Careful. Just the x. The 3 ain't going nowhere. Right? It's happy where it is. What's the 3 being raised to? A first power. So what's the only thing to a negative power that to? He's going to go down. Done.
Oh.
Rocked your word. So be careful.
I thought it was 3x and then... I did 3x and then 1 over -2.
Ah, okay. So I saw a few other people doing that. What is 2 to the negative 1 power?
-2.
1/2. Be careful. A negative power can never make something negative, ever. What's a negative power mean? Flip. How do you make it become negative? Multiply by -1.
But since the x is being raised to a negative, just the x is going to get flipped.
Exactly, right? Now what I'm trying to get at is a negative power means flip. I need everybody just to internalize that. A negative power means flip. We proved why that was true. We showed an example of why that kind of makes sense. How a negative power acts like division, so it would kind of go down and that would make the same answer. But now, negative power means flip.
Only the exponent though, right?
No, because we put the 3 up on top.
We just connect
Yeah, what
I'm
are
not
you
sure what that
flipping?
question means.
Like how
What are
you
you
would-
flipping?
Like how you put the X down, you know?
Okay? What's being raised to a negative power in this problem? What is being raised? X is being raised. So what's going to flip? X. Right?
So X is on top, so then it has to be on the
Exactly. So this becomes the 3 stays where it is, and those 2 X's go down there.
Could you have written it like a mixed number? 3 over 3
Yeah, that's what I did.
on X?
Oh, sure. That's the same thing. You write this 3 like that.
Yeah.
Hell yeah.
Oh, I like that.
That's a little weird.
Oh.
It's exceptionally weird because this looks more like a mixed number when it should be multiplication. So I'd rather like that. That's a little bit better. Yeah.
So, I think the way I remember it is because 12 is the bigger number, 3 has to go up there, and because 10 is the bigger
I like
number,
it. Good.
X is
That's the way I do it. That's what I said. I'm going to do it the way most of you guys did it first, and then I'm going to show you the better way to do it. Because obviously these negative powers, even though you should be able to handle them, if you can keep them from showing up, would you like to do it that way?
Yes.
Yes.
Yeah.
If they're there, you got to know how to deal with them. I understand that. But if I can keep them from showing up. So watch this. Okay, 12 divided by 4 is 3. Woo. How many X's cancel?
2.
No, you say how many left?
8.
8 cancel. How many are left?
2.
Where? Because like you're saying, because there's more on the bottom. I skipped the freaking negative power step entirely. If you think in your head, 8 X's in a row, can you see them? Over 10 X's in a row. How many cancel? 8 of them. How many left? 2 on the bottom. I don't bring negative powers in. Screw the negative powers.
Oh, I
I'm
like
with
that.
you. It's easy to make negative mistakes. You should be able to handle them, but you can be smart enough to not even let them show up. So there should be 2 X's left on the bottom because there's more down there to begin with. I love it. Exactly. That's the way I do these damn things. But it's nice that no matter which way you do it, it's the same answer. It's got to be. Yeah.
I think I just took it like a step further. I canceled all the X's, put a 12, and then all the X's on top are gone, so it's 12 over 4 X to the second, and then 12 divided by 4 is 3.
Oh, so you just did it in a different order. I did my 12 divided by 4 first, and then did my X's. You did your X's, and then it doesn't matter. As long as it all gets done at the end, right? All right, any other questions on that one there? You can always do 8 minus 10 and get negative 2. But like somebody said earlier, it's just convention to not end with negative powers. You go ahead and flip those down. If you have negative on the bottom, they flip up. If you have negative on the top, you flip them down. Okay. Personally, that just kicks ass. It's relatively simple to think about, hopefully. There's more X's on the bottom, so there should be some left there.
Okay.
As many left as are more than this. So now this guy's got a lot extra complexity. Do the numbers first. 3/18 reduces to, I don't want to see any 15s. Do you guys see where somebody would think that? Because of subtracting, you guys? But we know that 3/18 is 1/6. What's going to, now here's the way I handle this. I handle this way. You could do negative 2 minus 12. And get negative 14 and then flip it. But here's a kind of another way to do it, if you want to. What would flip? What's the only thing in there that wants to move? These. I already have 12 X's down there. When these come down, I'll now have 14.
So you don't switch them? You don't put the 12 on top?
Careful.
Or the...
What's the only thing in here that doesn't like where it is? That.
Yeah, but doesn't the other one have to flip? That one's coming. It
Say again?
stays there?
Which one?
If you flip it, it doesn't mean that the other one flips with
Why
it.
would that have to? The only thing that moves, a negative power means flip. Is this to a negative power? So those 12 X's can't go up. They would have to be to a negative power to go up, wouldn't they? The only thing in this problem that's a negative power is these 2 X's. They go down, they 14 on the bottom. Now if you did it the other way, if you did 1 over 6 and then negative 2 minus 12 is negative 14, then these 14 X's go down, you get the same thing I just got. Yeah.
I did a different way, where I took the reciprocal, and then all reduced to like a whole number, I got 6x to the negative 14. So that'd be the same thing with that fraction, so it's just with a negative x.
No, because you're 6, it should be 1/6. So you can't just turn this whole thing over. there's nothing in the problem that says you can just turn this whole thing over. But you can take a negative power and move it.
Negative 1 applies to that.
Yes, good. So let's do a couple real quick, kind of off of that idea. What if I had this? How do you think I would do that problem?
They make it as positive because they're
It's
like,
positive.
What moves?
11.
no, they
Yeah,
make it
these 11 M's go, and these 5 M's. That is when you would move both of them if they are both to a negative power. And now this is relatively easy. How many's left? 6. So the first thing I do on these kind of problems is make all my negative powers go away by just flipping those parts. Then I have nothing but positive stuff left. I'm not going to make a negative mistake then. Do you have to do it that way? Hell no. How could you do this problem instead? Negative 5 minus negative 11 is negative 5 plus 11 is 6. But do you see how that could lead very easily to mistakes? You have to keep all that in your head while you're doing this. I really don't feel like doing that. Not much room left up there. All right, so what about, what do you got, Jeff? I don't know. What's the other thing I want to do? Oh. Let's make that plus there. Yes, sir.
On that previous one, which one of those is the correct format to leave the answer in?
This here. That one.
Alright.
And then this one will be that one. Yeah. Thank you.
Because you had the 1/6 x to the negative 14. So that was
Yeah.
what I solved, right?
Good. That was if you did the subtraction and then brought it down. You get the same thing I did by bringing that down.
I'm just saying,
Yeah.
which one is
That
the
would be it.
problem?
Yeah. Now, do you notice, I mean, this is what's going to happen. We're not all comfortable with just this by itself yet, but everybody would classify this as an easier problem than that. Are you with me? Just because I threw more variables in there, but you just do that problem and do that problem, right? So what happened? And actually, the way I do this, and you don't have to do it the way I do it. You can certainly just go negative 5 minus 9, 4 minus negative 1. First thing I do is any negative power is going to move. So those 4x's and those 9m's are not going to move. Do you have to do it that way? No. I would desperately love it if people would do it that way because it just makes it so much easier to look at. And actually, to tell you honestly, I just do this in one step. I say there's 9m's there already. How many more coming?
5.
So how many are going to be there now? 14. There's 4x's there. How many more coming? So how many are going to be now? 15. I'm done.
okay, so it goes positive once it gets down there.
Now there's an intermediate step you can show yourself if you want to. Here's 4x's up there. You bring the 11 up there with it. There's the 9m's that are cool with where they are. You bring those 5m's down. And then you can add the exponents and you get there. It's really nice if you're able to do this little shortcut. How many's there? How many more coming? Bam. That's exactly how you can do that kind of problem. Notice how I keep ramping it up. So let's ramp it one more step up here. Yeah. Oh, let's not make it gross yet, though. Yeah, this will be fine.
God. I'm enjoying this.
Yeah. No, what I want you to do is just, and this is a weird way to say this, because this is not reality, but I want you to catch on to math's tricks. It keeps piling extra shit on it, and you don't care, because you know each thing I got to do is I just focus on that, do it. Then focus on the next thing, do it. What everybody does is they look at this problem like, look at that problem, holy shit. When your first problem is reduce 12 over 8. If you have a problem with that, you should be an 88, just to be completely blunt. But I really want you guys to realize, every piece of this is not as ugly as the whole thing looks. Can anybody tell me what's the very last thing I would do? Yeah, this on the outside. What's order operations say I got to do first? Inside. So that square is just going to kind of come for the ride with me. Yes, sir.
But so then did you just the 7 and the 2 just flip because they're both negatives?
I love it.
So it's just +7, +2.
So what I would do is, here's that square just coming for the ride. He's got the last thing I got to worry about. First thing I do is the easiest thing. Reduce 12 over 8.
4 halves.
3 over 2.
Yeah, so 3 over 2. That sounds better. And then like you said,
Flip those two.
you could do -2 minus -7. That's nothing really wrong with that. That's exactly following the properties. But I just feel like it's easier. That's going to go up. That's going to go down. That's a lot easier to look at now. And what happens with the B's?
B goes up.
2.
Yeah, these two B's go up. So I've just taken a minute to rewrite it with no negative powers, and now that's a lot easier to think about on my next cleanup step. So what do I get here? I get 3 over 2. How many A's are left?
5.
Oh, where?
On top.
And how many B's I got there on top? And so the last thing, like we said earlier, the last thing I do is that square on the outside. Square 3, 9. Square A5, A10, B20. Good. 2 squared, 4.
Oh, wait.
So you are completely allowed to attack a problem. Numbers, A's, B's, C's, D's, whatever the hell other variables are in there. There's not a damn reason at all that you got to feel like you have to do the whole thing at once somehow. I think that's what gets in people's way. Yeah.
So we flipped the 2 and the 7, but let's say the -7 started up top and the -2 was below, then our A to the 5th would just be on the bottom, right?
Yep.
That's the only, okay.
The only reason that 5 A's were on top is because there were more A's
There's
to
more to
survive,
stuff.
right? 2 of them die, 5 left up top because that's where more of them were.
Okay.
Cool. Yes?
Can an exponent of let's say, can an exponent of x minus an exponent of y? Like say if you're doing the division thing? You know what I mean?
Yeah, I know what you mean.
Kind of stuff.
For multiplication and division, they've got to be the same base. So if I had like y to the 8 over x to the 6th,
Yeah.
is this something to the second power? No, that's it. That's what it is. I can't do anything with that. If it was x to the 8 over x to the 6th, that would be x squared, because you got 2 left, right? But you've got to have like bases to be able to consolidate. The whole idea is consolidation. Why would I write this over this when 6 of them go away, I got 2 left? Why would I write this big thing? Let me just consolidate it. Here, I can't consolidate. Those are the y's, those are x's. Shit. Yeah.
Well, on the first problem, if you had a y, let's just say you had a y in the bottom, it would be y7 over x6 then. If you had a y in the
Oh,
bottom,
of course. Sure. If I had a y here, then those could cancel. Sure. Yeah.
What if the exponents are negative?
Then the only thing you do is flip it. Right? So if the problem would have been this,
Right.
your answer should be x6 for y8, they would just flip. These are all good answers, and good questions about how this stuff kind of works. Alright, so let me show you. That's not the ultimate badness. Let me
So
show
if
you.
you had like y -8 over x6, you would just bring down, there would be nothing on top anymore? Or would it be the 1
Oh,
on
okay.
top?
If it was
x,
y -8 over x6,
Yeah,
1 over x.
so these go down. And that's also a really good question, because what's left on the top?
yeah.
It's not a 0.
So
It's a 1. Good. There's always that understood times 1 just hanging around. He doesn't show up until everybody else leaves. Right? He steps out of the shadows. You know? So yeah, it kind of freaks people out when I always see. I've never really seen this, but I can't remember what I have actually seen. But people weren't sure exactly what the hell is supposed to be up here. It's that understood one now shows up because there's nothing else there, right? Like if I have x, I wouldn't write the 1 there necessarily. I don't need that. But x divided by x, now all of a sudden the 1 shows up because the x's went away. Is that cool? Okay. Cool, maybe. All right. So here we go. Here's the absolute worst problem you would see from me. You thought that was it, but no. Yeah. Oh, well, let's see. What do you want to make this? So the only real thing I did, I added one more variable in there, which by itself should not be that big a deal. And I made the power on the outside itself negative. Yes,
Is that a Z or?
Yeah, it's a Z.
Okay.
Yeah. So what's the last thing I would do? Yeah, that negative power on the outside. So it's just going to come for the ride. Don't lose him. First thing I do is the easy part. Yeah, that's 2 over 3. Is that cool? What happens with the W's?
They all go down to the bottom.
Yeah, these 7 go down with those 8. So how many do I have down there now? Careful. 15. I'll let you absorb that for a minute. Again, you could, if you wanted to, -7 minus 8 is -15, and then those 15 would drop down to the bottom. I just personally like this better. The negatives never have to show up, really. What happens with the x's?
Go up.
Yeah, those go up. So I had 4 up there. There's 2 more coming, so now I got 6. The biggest mistake on the z's is people cancel them out. You can only cancel them out if they're exactly the same. Are those the same? No. In fact, look at it the same way. What happens with these? What moves? Yeah, these on the bottom, the 2 negative power. I got 5 up there. I got 5 more coming. So now on the top I got 10 of them. And again, 5 minus -5 is 5 plus 5 is 10. You can always do the division means subtraction thing if you like that better. Not everybody likes this way. I always got to remind myself that. It just makes so much more sense to me.
So much better.
And of course the -3, don't forget him. Am I done on the inside? Yes, I can't do a damn other thing on the inside. Now watch, here's the outside. Now here's how you look at this. There's 2 things this wants me to do. Flip and cube. Nobody ever said I had to do both at once. So I'm going to flip everything and then cube everything. Right? I'm going to do what that says to do. There's no reason to do it all at once. So I'm going to flip it, which means now what am I going to have on the outside? 3, because I've done the negative part, right? I'm going to flip everything. So now what's on the top?
3 W.
3 W.
Good. Because everything has to flip. And on the bottom? Good. What was on the top is on the bottom, what was on the bottom is on the top. Say again? I could, but when people do that, they lose track of which negative. These become positive because they're flipping them, but they would be flipping them because of this dude. And see, I don't even want to explain that any further. Do you see what I'm saying? This flipped because it was to a negative power. If I apply this negative, everything has to stay the way it is, it just has to move. But people forget, and then they make that positive 7, they make that positive 2, and then the whole thing goes to shit. So I'd rather just follow order operations. Do the inside first, and then start applying the outside, the exponent on the outside, right? That'll keep me straight as to which negative is making me flip. That's a sentence you never hear outside of math. So, now what do? 3 cubed, 27, w to the
45th.
good, 45th, you got to multiply. 2 cubed, 8,
18.
good, x to the 18th, z to the 30th, I love it. You're multiplying those powers because you're raising them. Ooh.
How come it's not 10 times 10 times 10? Or 15 times 15 times 15?
Because they don't have a 10.
When you cube it though with the W, you know?
I'm not kidding. Nowhere in here is there a 10. There are 10 z's down here, right?
And we don't know
So
the
what
value of
is z to the 10th cubed? Why would 10 cubed would be like you said? 10 times 10 times 10? 1,000, right? Z to the 10th cubed would be z10, z10, z10. 10, 20, 30, right? So that's what I mean when I say that, and I know I always get somebody who looks at me like I'm crazy, but there's absolutely no 10s anywhere in here. There are no 10s. What's that then, Jeff? That's keeping track of how many z's you got, so you don't have to write them all z, 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 z. No. Z to the 10th, right? So it's not going to act like 10 cubed would, because it's not a number. It's a power. It's got to act differently. This is where I always get people that start to tell me, math always changes. Every day it changes. Yesterday you said this, and now you're saying this. I add now, and no, never changes. Can't change. The minute you think it did, you come see me. Because that means you're looking at something wrong, right? So any other questions? Now again, this is even worse than what the book's got. So I think if I gave you a problem like this, I may make it just a little uglier and make it a bonus problem. The ugliest the book gets is like this almost, yeah. Yeah, basically that. Okay. So let's see. Yeah, one more thing. We'll go a little. Have any of you, any other questions on powers and stuff? Yeah. So 40 says m to the... Is that the one you're looking at, right?
No,
Which section are you in? 5-1?
5.1, yeah.
Okay. Fine. Cool. So what the hell? How does this work? What would m10 over m squared be?
M to the 8.
M to the 8. What's m? I don't know. So something to the 10th divided by that same thing squared is that thing to the 8th, because of course there's only 8 left. So 9x to the 10th over 9x squared is 9x to the 8th.
Does it still need those parentheses?
I got 10 of these, divide 2 of these away, so now I got 8 of these. So effectively those parentheses make it act like one thing. Whatever 9x is, just like whatever the hell m is.
But you don't like...
Now you could, you could do this. I would not go any more than that, because 9 to the 8th gets pretty big, and there's no real purpose served by writing that number out. 9 times itself 8 times, it gets pretty big, pretty quick. Right? Okay, cool. Let's see if I missed anything. Oh, and I was telling somebody earlier how I could be really evil and give a problem sort of like this, About like that. I actually used to do that. I can't believe I was more evil before. Normally I keep saying, when I get older, I get even more evil, but if somebody starts working like crazy, But what's this answer?
1.
Yeah, 1. Anything to the 0 is 1. Aren't you happy you didn't have past Jeff from the past?
That's where all that bad stuff came from.
Sorry. But I made a point of it in class, I think is the point. I made a big point of it in class, and then I gave it on the test, and everybody was working their ass off in here. And the 0 just kind of left. It's like, man, you took away the easiest part of the whole point. But don't, I'm not going to do that to you. Don't just start putting 1 and everything, just in case. One of them's 1.
When the negative exponent's on the top and the negative exponent's on the bottom on the same variable, then it just goes a higher, whichever one they both flip.
Yep.
To go positive.
Yeah, we've seen that a couple times already.
Cool, and then that's just, it's going to be...
So if I had a negative 2 over a negative 5,
yeah, it just...
those go up, those go down.
And let's say there was a bunch more variables, you would still have an A on the variable,
Yeah.
A on top and A on the bottom.
Just by putting more variables in, can never change what these do.
Okay.
These will always do that, even if there's some X's and W's and 11 and all this other crap. This piece of it will do this.
Okay.
I like the way you said that, because that's the big key of mathematics, is when you have this ugly, huge problem, and there's D, and there's E, and there's F, and there's on the bottom, and there's all this shit. I mean, this piece right there will do that. Then I look at the B's. I see that those 4 would come up, and now there's 11. That's exactly how you attack a problem. Look at the numbers. Look at the A's. Look at the B's. Look at the C's. So it's a series of small, easy problems. But when you look at the whole thing, right? But it's really just that problem. Oh, and that problem. Oh, and that problem. Okay, maybe. Okay, so one application of exponents. And I don't know if any of you are going to go into a science class after this. There are a few science classes that have Math 90. They don't only have like a Math 103 or 110 prereq. So one thing they desperately want us to teach our 90 students is scientific notation. Because in science you use this all the time. Maybe it's the first word that gives it away. But when you want to describe the distance between planets, between stars, let's say, right? I don't want to have to write all those frickin' zeros out because it's pretty damn far apart. When you want to describe the width of a human hair, I don't want to write all those zeros out in the front. I want to have a quicker way to do it. So I want to come up with, so for example, if I had, let's start with like this number. There you go. This is going to feel a little bit like the way that I introduced exponents. I don't want to write all those stupid zeros out. So the way this works, let me just show you where this comes from. The first step is to realize that this is just this. All right, 4 times a billion. And can somebody help me out? How would you write, and yes, this is the one place where the X for times is still used in scientific notation. What would this be? How many tens would this be? 10 to the what power?
8.
Yes. 10 to the first is 10. 10 squared is 100. So the trick is just count the zeros. This is 3rd, 6th, 9th power.
Oh, nice.
So now, even before, I know some of you guys have seen scientific notation. You know that's what it is. If you've never seen it before, that is just the truth. 4 billion is 4 times a billion is 4 times 10 to the 9th. I mean, that's just the truth. You can't escape that. Right? But now I realize, okay, that's scientific notation. That's what scientific notation does. It sucks all the tens out of something. I don't know if anybody else puts it like that, but I like to think about it. It sucks all the 10s out of this big-ass number. And so I'm left with that 4. And then this gives me an idea of how big that number really is. The most important part of this number is the fact that it's a billion. Right? It's 4 billion, but the most important fact is it's on the order of a billion. How you doing? If I told you I had $4 billion, I'm like, no, I made a mistake. I actually have 3 billion. I'm like, it's freaking billions, man. That's all I care about is the fact that you're talking about something billion. Okay. So what if I had a really small number? Let's not go crazy here. Let's say that. How do I write that as a fraction? What place is that in?
10 to the
Yeah, tenths, hundreds, thousands, 10,000. So it'll be 4 over 10,000, which is 4 over 10 to the fourth. Now watch this. If I wanted to force this dude up, does anybody know what would have to happen to tell me he really wants to be down? It would become negative power. Which might be me finally answering somebody's question from earlier. That's an example of me doing the opposite. If I bring something up that doesn't want to move, it's got to become a negative power to tell me, no, dude, I want to be, put me back down there, please. But scientific notation is in this format. Something times 10 to the something. So, of course, some of you guys know the shortcut. Thank God we don't have to go through all these steps. We just have to count the zeros. 3, 6, 9. And I really suck with left and right. I still do. When I was a little kid, I was worse. I trouble with yellow and white, too, for some reason. But I still have to go like this to know this is left because it makes an L. So I hate the fact that people taught scientific notation, move it left, move it right. Especially because it depends on if I'm going this way or that way, which way you move it. So to me, it's easier to remember big number, positive power. Because that means you're multiplying. Small number, negative power. Because what does the negative power really mean? It's down, so you're dividing. That's why it becomes small. That makes sense. Yep.
Hey, could I ask you a question? Hopefully I don't confuse anyone. Like, right there you obviously have 9 zeros, and the 1, like, is kind of the place marker for the 9 zeros or whatever. But down there, you have 3 zeros.
4 zeros.
Well, your decimal is...
1, 2, 3, 4.
Oh, because you're in the 10,000.
I love it. Yeah.
Could you just leave it or
No. Scientific notation specifically is number times 10 to the power.
so it would have to be?
Yes, you have to bring it up. Yeah.
Isn't it always like 4, like for that example, 4 point something times 10 to the, like 4.0 times 10? And
It could be.
one of the,
It could be. It could have decimal something or other. But this number has got to be between 0 and 9. Actually, 1 and 9 if you want to get down to it. Right? It's got to be between 1 and 9, because if it's not, that's more 10s you didn't suck out yet. Yeah.
So I got mine came out right, but I used not the 4 zeros from the 10,000. I used it from the...
Exactly. So now the shortcut, why would you do this crap when you can just go, how many times do you have to move the decimal until you have a single digit? 1, 2, 3, 4. Right? So that's why it's 4 times 10 to the negative 4.
So it would be wrong. It would be wrong if you wrote like 4 dot instead of x 10 negative 4.
Not really. I've seen that, but that hasn't really taken on. But I've seen that.
Okay, but mostly it's the x for the
Yeah.
multiplication. Of
Yes. So real quick, let's do a couple without going through the whole steps here. If I had 0.00000087, it's small. So what's the exponent going to be? Negative. Right? Left and right sucks. How many times do I have to move the decimal? 1, 2, 3, 4, 5, 6, 7. Good, because you got to stop when you have a single digit in front of the decimal, right? Because if I stop there, that's effectively 8/10. There's another 10 I haven't sucked out. If I stop over there, then I got 87. Oh crap, I still got a 10. I got to stop when there's a single digit. And after all the talking, I forgot, was it 7? So negative power because it's small. 7 because we had to move it 7 times. 7, yeah. You guys kind of with me? And that's the idea of this just applied a little more quickly, a little more efficiently. So of course, if I had that, the deficit, as it knows, not quite that big yet. Give us a few decades. So the exponents can be positive or negative. Positive, big. And then commas is awesome. 3, 6, 9, 12, 15. Right, because I gotta move the decimal until I get to one digit. So 3.51. So I got one digit in front of the decimal. That's what I know to stop.
Can you do
And then it,
351 times 10, 13?
let's do that. So if I move it 3, 6, 9, 12, 13. So that would be 351 times 10 to the 13th. Doesn't that have more tens in it? 300 is 300. There's still tens I haven't taken out. So the whole idea of scientific notation is to have a number and then to, what's the word? Accumulate? No. Screw it. Huh? Consolidate. Okay, sure. Consolidate all my tens in one place. And it gives me a really quick way to compare things. So really, the mistake I had here was we didn't go far enough. We've got to go 2 more spots. So it should be 10 to the 15th. So if I say there's a star that's 4.87 times 10 to the 5th light years away, and there's another star that's 2.91 times 10 to the 6th light years away, which one's closer?
What?
Top one.
What's the important number? Is this the important number?
No.
No, this is the important number, man. This is closer, isn't it? That's 10 times further almost, right? Not quite 10 times, but the important thing is it's some amount bigger. So that's why in astronomy and stuff, we just say, we actually use this phrase, on the order of 10 to the 5th. It's a way of getting to the point quicker. I got a distance on the order of 10 to the 5th. I got one on the order of 10 to the 6th. You're further than me. Woo. Right? That's the exact conversation that happened. No. Are you guys feeling a little loopy? Are you guys with me? Okay. Somebody cut my teeth with something. All right, so that's the last part of section 5.2. Is scientific notation stuff.
That was what, 5.2?
5.2, yeah.
Are they ever going to make you go from the 2.91 times 6 into the number?
Yeah. So the other way to do this, complete this idea. If I had 1.09 times 10 to the negative 4, how do you write that as a pure number? Yeah, which direction am I going to move?
Right.
This says I'm going to make it a small number, right? So see, this is why I hated, now let's go ahead and move this number. Now watch, this is really cool. When it's a negative power, I've got to move it once to get around that whole number, right? So how many more times do I have to move it? So there's always one less zero in front. If it was a negative 4, I've got to move it once, and then I have to move it 3 more times. I need 3 zeros there. You with me? So if it was 10 to the negative 11th, I just need to put 10 zeros there.
Decimal acts as a zero in a sense, or
It's just a placeholder.
Say again?
It's like just a placeholder. Like,
Yeah, just a placeholder. Yeah, those zeros. If you've had any science and anybody ever heard of something called significant figures? Or even significant digits? If not, they might be in your future. And they deal with if zero important or not. But real quick, this is why I hated left and right. If you move this to the right, then the power is negative. But when the power is negative, which direction do you move it to go back? Oh, God. If I just remember small, I don't care which way I'm going then. Start small, it's negative. If it's negative, it makes it small. Doesn't matter. I don't remember left in this case, but right in this case, screw that. Small means a negative power. Negative power means small. Nice and to the point, right? So if I had 8.97 times 10 to the 11th, Yeah, I got to move once, twice. So then how many zeros will I have?
9.
9. Whew. Cool. All right, that's enough for today. I'll have that quiz graded tomorrow. And I'll have the practice test ready for you guys tomorrow.